Today we're going to take a look at this probability review. So there are 40 students in a theater class. Of these, 11 take dance, 14 take voice, and 20 take neither. Draw a Venn diagram. Okay. Oops. So it looks like we have dance and 14. Or dance, sorry, and theater. 20 take neither. We don't know how many take both, so we have 11 minus X over in dance, 14 in theater, or in voice. Sorry, that should be a voice. So total, this is 40. So 11 minus X plus 14 minus X plus 20 has to equal 40. So we have 20, 30, 45 minus X equals 40. So X is 5. So we have 5 here, 6, and 9. So find the probability of dance and voice. So that would be our 5 out of 40. Find the probability of voice given that you're not in dance. So if I highlight all the not dance, there's our not dance. So that's what we're looking at, is of those 29, how many are in voice? Well, that would be 9 out of 29. The next one, for events C and D, it is known that the probability of C is 0.7, the probability of C and not D is 0.25, the probability of D is 0.2. So I'm going to try drawing a Venn diagram again. So we have C and D. So we know the probability of C and not D is 0.25 out here. So we have X again in the middle, 0.7 minus X, 0.2 minus X. Add these all together. Sorry, the writing is getting a little messy here. The stylus is not working the greatest. Plus 0.25 equals 1. So 0.7, 0.8, 0.9. So 1.15 minus X equals 1. So that means in the middle here, 0.15. So over here would be 0.55, 0.05. So find the probability of C and not D. So what number is in C and not in D would be the 0.55. Explain why C and D are not independent. Well, to be independent, the probability of C and D equals the probability of C times the probability of D. So the probability of C and D is 0.15, and that does not equal the probability of C times the probability of D. So number 3, two events A and B are such that the probability of A is 0.6, the probability of B is 0.2, and the probability of A given B is 0.1. Find the probability that they both occur. All right, so let's see what we can do here. So we don't know X. We know this is 0.6 minus X and 0.2 minus X, but we don't know what goes on the outside. So let's use our conditional probability. The probability of A given B equals the probability of A and B divided by the probability of B. So if we fill in some blanks here, we can say 0.1 equals, we don't know that top number, over 0.2. So if we multiply by 0.2, X equals 0.02. So we could go back here, and we know the probability of A and B is 0.02. So we have 0.58 here, 0.02, so 0.18. And if we add this all together, let's see, 0.6, 0.78, that means 0.22 has to be on the outside. So the probability that both events occur is 0.02. At least one occur. That would be everything in the circles. So we do 0.58 plus 0.02 plus 0.18. So we have 0.78. Exactly one event occurs would be 0.58 plus 0.18, so 0.76. That B occurs given that A occurs. So we know A happened, so we know it's one of the 0.6, and that B occurs would be 0.02. Jack does 3/5 of the jobs around the house, and Jill does the rest. If 35% of Jack's jobs are finished properly and 55% of Jill's are done properly, find the probability that jobs around the house will be done properly. So, I might draw a tree diagram. So we have Jack and Jill. So this is 3/5 and 2/5. And I'll just put like a yes and a no, maybe, for properly and not done properly. It's 35% that his are finished properly. So 0.35, so that would be 0.65. 55% of Jill's are done properly, so 45 are not. So if they're done properly, that would be Jack is done properly, so the Jack branch, plus the Jill is done properly. 2/5 times 0.55 times 0.35 plus 2/5 times 0.55. We got 0.43. By Jill, if it was not done properly. So by Jill, if it was not done properly, it would be the 2/5 times 0.45. But this is a conditional, but if it was not done properly. So when I look at this, I'm going to find each of these branches here. So 3, sorry, you can't see what I'm typing, times 0.35. So this branch is 0.21. 3 divided by 5 times 0.65. This branch is 0.39 times 0.55, 0.22. And then we have 2/5 times 0.45, 0.18. So if it is not done properly, we have 0.39 plus 0.18. And if it's not done by Jill, so that would be the 0.18. So you have 0.18 over 0.39, 49.57. So the next one we're looking at, Max travels to school each day by bicycle and by bus or car. The probability that he travels by bus on any day is 0.6. The probability he travels by bicycle on any day is 0.3. Create a tree diagram which shows the possible outcomes for his journey on Monday and Tuesday. So we have, this would be Monday. So he could either bike, bus, or car. So we have 0.6, 0.3, so this has to be 0.1. So then the next day, bike, bus, car. Oh, this is a big tree diagram. Bike, bus, car. Bike, bus, car. So we'd have 0.3, 0.6, 0.1, 0.3, 0.6, 0.1, 0.3, 0.6, 0.1. So if we might, this would be bike, bike. So that would be 0.09. Bike, bus, 0.18. Bike, car, 0.03, bus, bike, 0.18, bus, 0.36, bus, car, 0.06, car, bike, 0.03, car, bus, 0.06, and car, 0.01. So hopefully if we look at all those, if we did this right, all of those should add to 1. All right, so we got it. What is the probability that he travels by bicycle on Monday and Tuesday? Bike, 0.09. By bicycle on Monday and by bus on Tuesday, bike, bus, 0.18. The same method. So bike, so our same methods, bike, bus, car. If we add those together, we got 0.36, 0.45, 0.46. So the next one. Max traveled by school by bicycle on Monday and Tuesday. What is the probability that he does not travel by bicycle on Wednesday or Thursday? So let's take a look at that one here. So we need all the numbers without bike, right? So we have, nope, that has a bike in it. So bus, let me delete that. So we got bus, car. So we have those, so 0.36, 0.45, 0.51, 0.52. So are all those the ones without the bike? I feel like I'm missing one. Let me check again. So let's see. So, well, if he does not travel by bike, well, what's the probability that does not travel by bike is 0.7. So 0.7 times 0.7, because that would be 2 days in a row. So we have 0.49, which I believe is the same if we were at to probability that in any 3 days, Max travels twice by car and once by bus. And once by bus, or twice by bike and once by car. So we have 2 cars. Okay, so we need, so this could be car, bus. So car, bus would be 0.1 times 0.1 times 0.6, but in any order. So there would be 3 of those, so times 3, plus bike, car, bike, car. So bike, 0.3 times 0.3 times car, 0.1, but we could rearrange that and there would be 3 of that. And by rearranging, I mean you could do car, bike, car, or bike, car. So if we multiply these together, 0.01, 0.1 times 0.1 times 0.6 times 3 plus 0.3 times 0.3 times 0.1 times 3, we get 0.045.